Hello, welcome back. So let's talk a bit more about this string literal. So in the example we've seen here, the entity, the painting with the title Mona Lisa, the Mona Lisa in here is a string, and in this triple, it is a string literal. The dot on the end here notes that this is the end of the triple. So we have to talk a bit more about these literals. First, they don't just have to be strings. They can be of any kind of data type. They could be an integer, a date, or a couple of other data types. For strings, you can additionally have a language tag after the string. So in example here, we have Leonardo da Vinci in English and the same entity, but described differently in French. And of course, you can have this for a lot more languages. So these strings, they are used in practice to give human readable labels to the entities that are described in the knowledge graph. Now, the actual entity, the painting, is called in this knowledge graph Q12418. But now imagine you work with a digital assistant like Google Assistant or Siri, and then you ask about paintings and it tells you, yes, how about looking at Q12418? And then you say, huh? Well, obviously, talking in IDs is not helpful. So instead, the assistant has to translate this into something usable for humans. So in this case, you would say, have you looked at the Mona Lisa? And because in these graphs, you typically have the information encoded in multiple languages, the same Google Assistant can give the name of the painting, the book, the author, whatever, in different languages, in English, in French, in Spanish, in whatever have you. So this is one of the main applications for having strings in these knowledge graphs. The AI doesn't really care about strings in most cases, but for humans, these are very helpful to label entities. There is a special rule for string literals in RDF, namely for a string, you don't have to write the data type after the string. So data types in RDF are based on XSD, so the standard XML data type description that you use in XML, for example. So for strings only, you can omit that this here is of type string. But for everything else, when you have a number, an integer, a date, you have to give the proper data type description afterwards. So here, for the details, have a look at another W3C standard, which talks about data types. So things to remember for now, you can have string literals, but the string literal can only appear in the object position of a triple. You cannot have a string as the subject or the property. For a literal, you can have multiple data types like string, and strings are kind of special in that you do not have to specify the data type string. Okay. There is another detail that I'll just mention briefly now because you might encounter it in a few examples, but don't get too confused about it. There is something called a blank node in RDF. Basically, there's an entity that we do not give a name. We don't give a URI. For example, here we have part of the painting, the Mona Lisa, and then we want to talk about something in this painting. But we don't want to give this part here an additional name. We don't want to give it a URI. So in RDF, there is a way to express something without naming it. And this is called a blank node. In the serialization down here, you can see this is indicated with this underscore. So there is something, but we don't give it a name. So it's an unnamed node, it's a blank node. And then we can talk about that in this painting here. We have, for example, a cypress tree. which again has a normal URI pointing to the DBpedia knowledge base. Talking more about DBpedia, so one entity you've seen there is Leonardo da Vinci. So if you go to this URI, you will see something that looks almost like a normal web page. You have some information about Leonardo da Vinci, and then when you scroll down, you have lots of additional attributes and information about it. One important detail about DBpedia URIs is that when you look up a resource like Leonardo da Vinci and DBpedia, you will get a different URI back. So you will notice that you type in dbpedia/resource, and when you look at it in a browser, it suddenly became dbpedia.org/page. And that's because of something that's called content negotiation. The DBpedia server noticed that you are accessing it through a normal web browser, which is something a human would do. And humans don't do very well reading RDF. So what it will do is a redirect to a page with normal HTML that you can look at. However, if you access it from a system, from a program that wants to read the information about Leonardo da Vinci, then it's going to redirect you to a page that has actual RDF data. And then it will have the URL/data/ in this case, Leonardo da Vinci. So you have to be careful when you write down URLs. A common mistake that I see beginners make is that they just copy and paste something they see in the browser. And when you look at it in the browser, you get /page, which is an HTML page. But this is not what we want. What we want is the RDF graph. So you have to use /resource because this is the proper canonical URI that you're using in the system. Let's try this out on another task on the worksheet. So in task number 7, you go back to DBpedia, look at Concordia, and then look through the information that's given there. And one of the information is about the homepage of Concordia University. And your job is to find this information and write it in form of a triple: subject, property, object. And then also add this triple to the graph that you've made in part number 1. And when you're done, I'll see you back in the next lecture part. See you then.